So welcome everybody to this latest video on 162 Math, and in this video we'll be going over the Aqa Gcse Maths of 2022 Higher Paper 3 Advanced Information regarding the Algebra section. And in this video we'll be going over some general advice, what topics are going to be appearing in this section before going through some past exam questions that cover all of those topics. So before we get started working through some revision questions, let's just have a closer look at the algebra section for the paper 3 higher paper of 2022. So what I've got here is basically a side-to-side comparison to what is given on the higher advanced information and what is given on the foundation. And as you can see that there are some topics that do overlap. So what I would say is that these topics are more likely and not 100% guaranteed to appear at the start of the higher paper. So therefore means that the questions might be either 1 mark or maybe 2 marks, but also at a lower grade as well. And those topics are simplification, which basically means collecting like terms, which again is a very popular multiple choice question nowadays. Roots and turning points, that one is a bit of a surprise that could be potentially something that's good to do with a multiple choice, particularly with appearing on the foundation, because obviously on the foundation you're not going to have completing the square. It'll be more of a case of giving you a diagram, and then from the diagram writing down what the turning points are and writing down what the roots are. So I wouldn't say there'll be anything regarding completing the square, and if the completing the square was going to be on there, then it would be written as an individual topic like it has on the previous 2 papers. The next one is arithmetic and geometric progression. Now again, these questions, as you will see when we go through some example questions, are very popular multiple choice questions where you're given a set of numbers that appear in a sequence and you've just got to state which one is arithmetic and which one is geometric. And also with the nth term as well. Typically, when you're practicing, you probably assume that these questions would be worth 2 marks, but they could also be 1 mark, as again, when we go through some past exam questions, you will notice that as well. So I would say that the ones highlighted in yellow are more likely to appear at the start of the paper or the middle area of the paper, within questions 1 to 8, I would say, than appear anywhere later on in the paper. Now, a common question I've got asked is basically which questions would be worth a lot more marks. Now, I would be not where I am now. If I had a crystal ball and I could predict what the future is going to say. So this is just using my professional judgment as to which of these topics could potentially be worth more than, let's say, 3 marks. Now, simultaneous and linear simultaneous equations and linear and quadratic equations, they usually do have about 4, 5 or 6 marks depending on how much work you need to do. So expect that one to be a big mark question. With regard to this triple brackets, again, I've gone through a few examples and I've tried to research questions from past exam papers, and usually there may be roughly between 2, 3 marks in terms of those. With regards to composite functions, again, it's a really tough one. Sometimes I've seen ones that are worth 2 marks, some I've seen 3, some could be worth 4 marks. It really does depend on the complexity of one of the functions and then what you've got to substitute in. Now, although in some of the examples that we go through, it does involve inverse functions. Again, could that involve there? Well, I would say yes. Anything that's mentioned in previous exam lists could come up in small elements. So don't completely wipe out your memory of things that you've already been covered in the previous 2 papers. Just make sure that you've got them in mind to help you answer some of these questions. So now let's have a closer look at the types of questions you could get asked with regards to, or some explanation about what these are. Now, like I said, if you're wanting some detailed sort of lessons going through each of these topics, then I'll try and add some links in the description below. But obviously there's loads of videos that cover all of these topics on the channel. So looking at equations, quadratics, again, you will find that a lot of these topics are linked. So for example, in terms of dealing with quadratics, that can also be linked with simultaneous equations. It could also be linked with roots. Turning points, I would say, is unlikely because completing the square is not on there. But again, potentially, you've got quadratic graphs. So you could get asked to factorize a quadratic equation and then go on to plot it. And again, that kind of comes over there. Quadratic manipulation just means dealing with quadratics. So I would say it could be a case of rearranging. So that could be linked with the simultaneous equations question. Factorizing, again, I would say that could be involved in the simultaneous equation question. So I would say that expect quite a lot although there's a lot of algebra topics listed in there, I would say a lot of these are going to be combined into one single question. So just be mindful of that. Now, exponential graphs, again, what you want to know is be able to plot the graphs and recognize an exponential graph, and also look at its properties in terms of when it's going up. Always remember that regardless of the exponential graph, it always intercepts at 0, 1, and always has this kind of shape or that kind of shape. In terms of, so let's just quickly go through. So quadratic equations, just recognize it could be using the formula, could be factorizing, could be completing the square, although that would probably have been mentioned. Could also be difference of two squares. Simultaneous, linear and quadratic, again, just make sure you know how to do those, because again, that's most likely going to be a big mark question. Manipulation, simplification, that's basically collecting like terms, which could be involved in any algebraic question, including composite functions. Triple brackets is just exactly that. Factorization, again, is going to be linked with quadratics of just factorizing. Again, could be in a multiple choice question where you've got a single bracket. Quadratic equation, again, more likely it's appearing a lot. So roots, turning points, quadratic graphs, again, I would say all of these three are going to be in one question. Then exponential graphs, again, is just a case of either recognizing, plotting, and going from there. Composite functions, just be mindful that whatever letter is closest to the x is the first function. So again, this is the first function you need to substitute. This one is the second. So try not to read it from left to right, more right to left. Arithmetic sequences are basically where the difference between each of the terms is where you're adding or subtracting. Geometric is where you're multiplying. And again, in the geometric, when you think multiplying, you think it's always getting bigger. It can also go smaller. It just means that the common ratio is going to be a number that's less than 1. And the nth term is just that. It's just a case of finding the formula for the sequence. So before we get started working through these exam practice questions, if you're wanting a copy of the questions to have an attempt at before watching this video, then all you need to do is just click on the link in the description below. Otherwise, you can just either pause the video or have a go at the questions while we're going through them. So let's just zoom in just so we get a bit closer on the screen. So looking at the first question, it says factorize fully 144 minus 4x squared. So this question here is a difference of two squares. So it's a dots question, because we're subtracting two square numbers. So here, if I set up my double brackets, what do I have to square to get 144? Well, that's going to be 12. And what do I have to square to get 4x squared? Well, that's going to be 2x. And one's a plus and one is a minus. Now with this, we do need to factorize fully, because, and the reason for that is because looking at each bracket, you can actually take out a factor of 2. Now for this, all we need to do is just take 2 out. So that's going to be 2, and then we're going to end up with 6 plus x multiplied. And if I do the same with this one, so here I can take 2 out, and I'm going to end up with 6 minus x, leaving me with 4 and then 6 plus x, or 6 plus x, and 6 minus x. And there is my final answer. The alternative I could have done is, I should have noticed that 144 and 4 are a factor or a multiple of 4, so I can take 4 out, in which I end up with 4, and then I would end up with 36 minus x squared. And again, this is also a difference of two squares, so I end up with 4 and then 6, x and x, one's a plus, one's a minus, and you can see there that both of these two answers are exactly the same. Moving on to question 2, it says factorize, and here we've got a complicated, well, I won't say too much of a complicated, but a complex quadratic. And the reason why it is so, because we've got a coefficient of x squared that's not 1. Now with these questions, you can either do them by inspection, so in other words, do them in your head, or you can have a set method in which you do this. Now it doesn't really matter which one you go for, as long as the terms inside your brackets are correct and in its simplest form. So for this, I'm going to go through the sort of analytical way, or the algebraic way of working this out. So here, if I multiply the coefficient of x squared by the constant, I end up with minus 60. So what I need to do is find two numbers that multiply together to give me minus 60, but added together give me the value, the coefficient of x, which is 11. And here my two numbers are going to be 15 and 4, and it's going to be plus 15 and minus 4. So then with those two numbers, what I'm going to do is I'm going to replace that with the 11x. So I end up with 3x squared plus 15x minus 4x minus 20. And then I factorize the pairs. So 3x goes out. So I end up with x plus 5 minus, and then I factorize the pairs there, which is a 4. I've got x plus 5, and those two brackets should be the same if you've done it correctly. And then from this, I've got x plus 5. And in my first bracket, I've got 3x and I've got minus 4. And there is my final answer. Now, if you got to there straight away, which is definitely possible, by doing the working out in your head, and you write that, you'll get the 2 marks. And again, if you've got absolutely no idea what I've done with regards to the magic number or the steps in which I've done this, I strongly recommend that you watch the video where it shows you how to do just this. Moving on to question 3, it says write x and then 3x minus 4 equal 3x minus 9 equals 4 in the form of ax squared plus bx plus c equals 0. So looking at part A, let me do that bit first. All I need to do is expand the brackets. So I end up with 3x squared minus 9x equals 4. And then I want to make it equal to 0. So I end up with 3x squared minus 9x minus 4 equals 0. The next question then says solve the equation. So solve, and notice that this is exactly the same as this. And we want to give your answer to 2 decimal places. Now that means that this does not factorize, and we need to use the quadratic formula. So looking at this, and with it being 3 marks, now I know some Casio calculators have got the quadratic formula already programmed, so it's just a case of going through some menus. However, it's really important that you do show working out to get maximum marks. So a equals 3, b equals minus 9, and c equals minus 4. So then substituting those numbers into the quadratic formula, I end up with minus 9 plus minus, and then 3 squared. No, it's not, it's minus 9 squared minus 4 times 3 times minus 4. That's all square rooted, all divided by 2 times a. So then simplifying all of this, I end up with 9 plus or minus the square root of 81 minus 48, all divided by 6, which leaves me with 9 plus or minus 129, all divided by 6. And that's then what I type into my calculator. Now remember that the questions asked me to give my answer to 2 decimal places, in which if you type that into your calculator, you should end up with a correct answer of minus 0.39 or 3.39. And they are rounded to dp. Moving on to question 4, it says solve 5x squared minus 10x plus 4 and give your answers 2 decimal places. So again, we're using the quadratic formula straight away. And so looking at the equation, we need to make it equal to 0 first. So I get 5x squared. Try and keep your x squared positive. It's not always important, but I would say it's usually the way that it's done. Minus 4 equals 0. So here a equals 5, b equals minus 10, and c equals minus 4. So then substituting those numbers in, we get x equals minus 10 plus minus 10 squared minus 4 times 5 times minus 4. That's all square rooted, all divided by 2 times a, which is 5. Then simplifying as much as I can, and again you can use your calculator to help you with this. So minus 10 becomes plus 10. Then we've got minus 10 squared, which is 100, 4 times 5, which is 20, times minus 4 is minus 80, all divided by 2 times 5, which is 10. So then simplifying all of that, get 10 plus or minus 180, all divided by 10. I can then type that into my calculator, in which I get an answer of 2.34 or minus 0.34, and they are two decimal places. Moving on to question 5, it says the equation of a curve is y equals x plus 3 squared plus 5. Circle the coordinates of the turning point. Well, the turning point is, well, the x ordinate is the value of x that makes the bracket equal to 0, so that's going to be minus 3. And the y ordinate is the constant that is outside the bracket, which is 5. So I'm looking for the coordinate of minus 3, 5, which is our last option. Then moving on to question 6, it says that a curve has the equation of y equals x squared minus 6x plus 17. A turning point of the curve is at A8. By completing the square or otherwise, work out the value of A. So for this, what we've got to do is use completing the square for y equals x squared minus 6x plus 17. So y equals, and I set up my format of completing the square. Let's just change my pen. So I halve this coefficient of x, that becomes minus 3, and I take away whatever digit is inside the bracket squared. So that then becomes y equals x minus 3 squared plus 7 minus 9. So that's x minus 3 squared plus, nope, it's going to be minus 2. In which then my A value is going to be 3. For part B, then says the turning point of the curve for the curve y equals x squared plus 4x plus b also has a y ordinate of 8. Work out the value of b. So let me just write that down again. So here I've got this equation. So y equals x squared plus 4x plus b. So from this, I need to use completing a square to factorize this. So I've got x squared, or x plus 2 squared plus b minus 4. And then, so from this, what I've then gathered that because the y ordinate of the turning point is 8, then this must equal 8. So therefore, b should equal positive 12. Moving on to question 7, it says that the turning point of the graph y equals x plus a squared plus b has an x ordinate of minus 2. 3, 1 is another point on the graph. Work out the y ordinate of the turning point. So let's have a look at the factorization. So we've got x plus a squared plus b. Now we know that the x ordinate of the turning point is minus 2, so that means that a must be the opposite of that, so it must be plus 2. So y equals x plus 2 squared plus b. Then from this, what we then got to do is expand the brackets. So y equals x plus 2 plus b. And so y equals x squared plus 4x plus 4 plus b. And then from this, what I can then do is substitute the coordinate in. So when x equals 3, y equals 1. So if I substitute that into there, the cursor is annoying me, so bear with me. Let me just get rid, or just make it ridiculously small. Oh. And back to the question. So here then we've got 1 equals, and then it's going to be 3 squared plus 4 times 3 plus 4 plus b. So then what end up is 1 equals 25 plus b. So b therefore must equal minus 24. Moving on to question 8, it says Mira is using a graphical method to solve 2x squared minus 3x equals 0. She draws a graph of y equals 2x and a straight line on the same grid. Here is the graph of y equals x squared. And it says complete her method to solve 2x squared minus 3x equals 0. So for this, what we need to do is we need to draw y equals 3x. Now the reason why where I've got that from is if I've got 2x minus 3x equals 0, well, if I take the 3x over to the other side, oh, don't know why I've put a cube there. Just get rid of that. equals 3x, then these are the two equations that I need to plot. So I need to plot y equals 2x squared, which is what Mira has done, and I need to plot y equals 3x. Now y equals 3x, again, you can do a table of values. It's going to be a straight line, 0, 1, 2. 3 times 0 is 0, 1 times 3 is 3, 2 times 3 is 6. So my coordinates of that straight line are going to be going through those points there. And again, if I draw my line through those, and again, this is going to be really difficult to, well, not that difficult, but time consuming to go through each of those points. And let me just make sure that it does. So there is the line of y equals 3x, and I think one of those is definitely out. It's up a little bit, and there we go. So that line there is y equals 3x. So the next question then says, oh, we then need to complete a method to solve it. So looking at this, you can see that the x ordinates of where it crosses the y-axis or the x-axis. So solving this would be x equals 0 or 1.5. It then says that Levi is solving 2x squared plus 5x equals 0. He uses this method, and so this is what he's done. And it says to evaluate his method and his answer. So for this, well, for starters, there's a couple of things he's done wrong. Is at this point here, you can't divide by x because x could equal 0, as x can be 0. So that's one point. And also is that you should have possibly two answers. So what you should have done is he should have factorized at the start to get two solutions, not one. So for this, what you should have, now again, sometimes you can, when you got these types of questions, you can give the right answer and then compare this answer to whatever the person has done wrong. So for here, we've got 2x squared plus 5x equals 0. So if I then factorize this and take the x out, I end up with 2x plus 5 equals 0. So either this equals 0, which x equals 0, or this bracket equals 0, which x equals minus 2.5. So Levi's only got one answer, and he's missed out the answer of 0 because he didn't factorize. Moving on to question 9, it says, here is a sketch of the curve of y equals 2 to the power x. On the axes above, sketch the curve of y equals 3x, 3 to the power x rather. Now with 3 to the power x, what you've got to remember is that it's going to be a little bit steeper, and the line you should have should look something like this. Now at 1, it should cross at the same point, so it should both cross at 1, or y equals 1. And this line needs to be above the curve, so above y equals 2 to the power x, and after 1, or after 0 I should say, it needs to be below y equals 2 to the power of x. And again, if you're not too sure, you could do a table of values. As long as it takes you less than 2 minutes, it should be absolutely fine. Moving on to question 10, it says draw the graph of y equals 0.8 to the power of x for the values of x from 0 to 6. And so here we've got a table of values. Now, again, if you're not too sure how to do this on your calculator, you could do each of the values individually. Well, let me just remind you how to do this on your calculator. So if you press mode and setup, I know this calculator is a very old Casio calculator, but the general setup should be the same. And what you want to look for is table. So if I press 7, now with f of x, treat that as y. So what you want to now do is enter the formula of x. So 0.8 to the power of x, in which you might have to use shift and the x, and I get that. If you get g of x, just bypass that. It's just because you can do two equations at the same time, and we really got one. Now the starting value of x is 0. The end value is 6. And the step is what the x value is going up in. Well, they're going up in 1s. And there we have our values. So the f of x values are the y values that you then need to write in your table of values. And so if I do that, and let me just roll that across. and which what we should have here is 1, we should have 0.8, and here we should have 0.64, then 0.512, 0.4096, 0.327. Again, I should get a thinner pen. I should have 0.3276 and then 0.2621. So from this, what we then need to do is plot these values as best as we can. So let me just scroll up a little bit, a tad, so I can see that table of values. Now again, some of the answers are to 4 decimal places, which is not ideal, as I can only really go, let's say, to 2 decimal places. So at 1 it's at 0.8, which is a nice one to plot. 2 is at 0.64, so each little box represents 0.2. 3 is at 0.51, so that's going to be about there. 4 is at 0.41, which is about there. 5 is at 0.32, let's call it 3.2. And at 6 it's at 0.26, which we will call there. The next thing we then need to do is to carefully join those points up, which again, this is the bit that I hate doing on the computer, and it should be a nice smooth curve. So your curve should look something like that, going through all the points that you have plotted. Moving on to question 11, it says that the point 3(1/64) lies on the curve y equals x to k to the power of x, where k is a constant. Show that the point a half lies on the curve. So the first thing we need to do here, and the question is worth 3 marks, is first find the value of k. So if I just write down, so find k first. So we do that by looking at the equation, and we know one of the coordinates. So let's substitute x and y. So 3 is my x value, and 1/64 is my y value. So I've got 1/64 equals k cubed. Now to find out the value of k, what I then need to do is to cube root 1/64, and if I do that, I end up with a k value of 1/4. So then the equation of the line is y equals 1/4 to the power of x. So this is my formula, and then what I then want to do is to substitute, so show when x equals 1/2, y equals 1/2. So again, you could write a statement that if a half lies on the line, then when x equals 1/2, y equals 1/2. So there's a fact that we're then stating. So let's substitute those into our equations. So when x equals 1/2, we end up with 1/4 to the power of 1/2. And if you type that into your calculator, so you might need to reset your calculator. And again, if you're still on the table format, so let me just get that back, and you want to reset your calculator, just go mode, and then you want comp, so number 1. So here we've got our fraction. Let's set up a bracket. Fraction 1. You could alternately, you could have just done 0.25. Close bracket to the power of 0.5 equals, and that equals 1/2. So 1/2 lies on the curve. And there we go. Moving on to question 12, it says circle the possible equation for the graph shown below. Now this is what we call a reciprocal graph, and so which of these equations represents a reciprocal? Well, it's going to be our second option. Question 2 then says this is a graph of y equals 2x right down the corner of A, and so with these they always intercept at 1, so then the coordinate of that point then is going to be 0, 1. Looking at question 13, it says f of x equals 1/2 x and g of x equals x minus x squared. Solve the inverse function of x equals g f of x. Now this is involving inverse functions and composite functions. So first of all, let's work out what the f of minus 1 is going to be. So first thing we need to do is make f of x equal to y, and then I need to make x the subject. So here I've got 2y equals x. So if I then swap them around, so the inverse function of x is going to be 2x. Then looking at the composite function, which is gf of x. So for this, what I need to do is I need to substitute f into g. So f is here. So wherever I see an x, I'm going to swap that with this. And if I do that, then what I end up with is gf of x equals, and it's going to be a half x minus a half x squared. And if I simplify that, and again I can use my calculator if I need to, what I should end up with is something that looks like this. So that there is my gf composite function. So the next thing left for me to do is now work with this. So I need to make those two boxes equal to each other. So I've got 2x equals a half x minus a quarter x squared. And then from this, what I can then do is to stick it all onto one side. So here I want to solve this for x. So if I take this over to, well actually I could take all of it over to one side. So let's start by doing that. So we've got 1.5x equals minus a quarter x squared. Now I've got a mixture of decimals and fractions. I don't really like that, so let me just convert that into a fraction. If you're not too sure, you can always use your calculator to help. Now this, we don't want to be doing too many dividing or anything like that, so let's take this over to the side to make it equal to 0, because it does look like a quadratic. So I've got a quarter x squared plus 3 over 2x equals 0. And then from this we then want to solve it. So here I could factorize. So if I was to factorize this, well, let's get rid of the fractions. Now again, you could use the quadratic formula. And if you were to use the quadratic formula, a equals a quarter, b equals 3 over 2, and c equals 0 to solve that. Or what you could do is just try and make this easier. So if I multiply everything, both sides, by 4, then a quarter times 4 is just 1. 1.5 times 4 is going to give me 6. And 0 times 4 is 0. So from this I can then factorize equals 0. So then my two solutions are x equals 0 or x equals minus 6. And there are my two answers. Looking at question 14, it says f of x equals 2x minus 3, g of x equals x squared. Show that the inverse function of f of 55 equals fg of 4. So again, what you want to do is work with these separately. So the first thing we want to do is find the inverse function of f. So y equals 2x minus 3. So y plus 3 equals 2x. So y plus 3 divided by 2 equals x. So the inverse function of x equals x plus 3 over 2. And I'm just going to put a little box around that. The next thing for me to do is to find fg of 4. So again, the fg function. So here I'm substituting, wherever I see an x, I'm going to swap it with x squared. So that then becomes 2x squared. Just put that in brackets, minus 3, which is 2x squared minus 3. And let me just write that again there. So these there are my two functions. So with this first one I need to substitute 55 into it. With the second one I need to substitute 4 into that. So if f minus 1 to 55 equals fg of 4, then what I end up with is well, substituting 55 in, I get 55 plus 3 divided by 2, and that equals 58 divided by 2, which is 29. And then if I substitute 4 into this, I get 2 lots of 4 squared minus 3. So that gives me 32 minus 3, which equals 29. And as you can see, those two things there are the same. Moving on to question 15, and again this is another functions question. So here we've got f of x equals x over x plus 2 and g of x equals x squared minus 2. Work out fg of x. Give your answer in the form of a plus bx to the power of n, where a, b and n are integers. So again, what I'm going to do is I'm going to substitute wherever I see an x in f of x, I'm going to swap it with this. So what I then get is x squared minus 2 over x squared minus 2 plus 2. Again, don't need to use brackets, but hopefully you can see what I've done there. So then what this then becomes is x squared minus 2 over x squared. And then I can split that fraction up. So I've got x squared over x squared minus 2 over x squared. This simplifies to equal 1. And then this, using indices, can be written as 2x to the power of minus 2. And so here a is going to equal 1. B is going to equal minus 2 and n is going to equal minus 2. With question 16 it says expand and simplify. So this here is a triple bracket question. So again, looking at this question, we've got to remember that this is a double bracket. So it's x minus 4 and then 2x plus 3y, 2x plus 3y. Now for this, if you've watched my video on triple brackets, I always try to expand the double brackets, the last two brackets first. So expanding this out, I end up with 4x squared plus, and then I will take it slowly. So let's go for 6xy plus 6xy plus 9y squared. And then simplifying all of that, I get that. And then I need to bring back the x minus 4 and then do the multiplying. So here I'm going to end up with 4x cubed plus 12x squared y plus 9xy squared. And then here I'm going to end up with plus, and then it's, well no, it's going to be minus. Let's do a different color so you can see what I'm doing. So then this is going to be minus 16x squared minus 48xy minus 36y squared. Now from this you can see that I really haven't got any like terms together or like terms that I can join together. So that, believe it or not, is my final answer. Moving on to question 17, it says f of x equals x minus 3 plus 4 and 4 values of x, and g of x 6x squared plus 3 for all values of x. And so work out fg of x, giving your answer in the form of what's in. Big mouthful there, but let's get through it. So looking at this then, again, what I'm doing is I'm substituting g wherever I see an x in f. So from this, it's going to look like 6x squared plus 3, all divided by 3 plus 4. Now with this, I can simplify because I can divide things by 3. I've got a common factor. So that then becomes 2x squared plus 1. Divided by 1 is just 1, so that's fine. Plus 4. And that then becomes 2x squared plus 5. So a equals 2 and b equals 5. Now you don't usually need to write down the a's and b's unless it says, but as you can see that there's this good sign I'm right because my answer for a and b are both integers. Moving on to question 18, it says that f of x equals 2x squared, g of x equals x plus 5. Circle the composite function of f g of x. So wherever I see an x in f, I need to swap it with the function of g. So that then becomes 2x plus 5 squared, which is my second option. Moving on to question 19, so you'd be glad to know we're moving on to our next topic, which is looking at geometric progression. So it says all terms of a geometric progression are positive. The second and fourth term are shown. Work out the first and the third term. Now in a GP, we've got a, and the second term is going to be AR. Next term is going to be AR squared, and the next term is going to be AR cubed. Now from this, if I look at this, if I do AR cubed over AR, well, AR cubed is 16, AR is 4, and then if I simplify this, I'm left with R squared equals, then 16 over 4 is 4, so R equals plus or minus 2. Now it says that the progression is positive, so that means that r must be positive 2, not negative 2. So then what I need to do then is, if I'm going in the opposite direction, I divide by 2, and to go in the forward direction, I times by 2. So the third term is going to be 8, and the first term is going to be 2. Then moving on to question 20, it says which of the sequence is a geometric progression, and you should have highlighted the bottom left. Question 21, it says the first two terms of an arithmetic progression are shown. The sum of the first three terms is 90. Work out the value of p. Now with an arithmetic series, it's just a case of knowing how do you get from one term to the next. Well, for this I need to add 4p. So if I add 4p to 5p, that's going to give me 9p. So my first three terms are those three. So p plus 5p plus 9p needs to add up to 90. I end up with 15p equals 90. So p equals 90 divided by 15. So p equals 6. Moving on to question 22, it says here are some numbers 10, 13, 15, 20, 27, 39. 10, 15, 20 is an arithmetic progression. Use three of the numbers to make a different arithmetic progression. So what you're wanting is where the difference between the three numbers is the same. So looking at this, then there's a couple of answers you could have. So you could have 13, 20 and 27, and there you increase, you've got pattern of 7 plus 7. So that's one possible answer. Another possible answer you could have is 15, 27 and 39, and where the difference is plus 12. Another answer you could have is 20, 15 and 10, where your difference is minus 5. Another sequence you could have is 27, 20 and 13, where the difference is minus 7. And the third possible answer you could, fifth possible answer you could have is 39, 27 and 15, in which we've got a difference there of minus 12. So any of those answers would be good enough to get you the 2 marks. Moving on to question 23, it says here are the first 4 terms of a quadratic sequence, and the question saying work out the expression for the nth term. So for this, what we need to do is, if I start by just writing down those numbers. So for this, we need to work out a double difference. So it's going to be 4, well, it's not going to be 4, it's going to be 15, and then plus 19 plus 33, and our double difference is 4. So then 2n squared is in our nth term. Now with 2n squared, so if n equals 1, 2, 3, 4, our nth term numbers, or 2n squared, is going to be 1 squared is 1, times 2 is 2, 2 squared is 4, times 2 is 8, 9, 18, 16, 32. And then I've got the numbers in the sequence, which are 11, 26, 45 and 68. So the next thing I then need to do is work out the difference between these numbers. So there I need to add 9, there I need to add 18, this I need to add 27, and this I need to add 36. Now from there, what you can see, so if I work out the difference is 9, because obviously the nth term is 2n squared plus the difference, and the difference here is 9, 18, 27 and 36. Now this becomes a linear sequence in which here the difference is 9, so then I've got 9n. What do I need to go from 9 to 9? Add nothing. So the nth term is therefore going to be, so the difference is 9n, so it's going to be 2n squared plus 9n, and there is my final answer for that one. Moving on to question 27. So again, I've not really left myself much room in this. It says work out the expression for the nth term of the quadratic sequence. So again, the difference here is 4, 6, 8 and 10. So the double difference is going to be 2. So n squared is in my nth term. So n squared is going to be 1, and then 4, 9, 16, 25. So then if I then work out the difference between those numbers, so that's plus 10, that is plus 11, that is plus 12, this is plus 13, and this is plus 14. So the difference, so if I just write plus diff, so the difference is 10, 11, 12, 13, which is a linear sequence, in which the difference then is going to be n plus 9. So then from this, what I've then got is, if this is what the difference equals, then just joining those two, I end up with n squared plus n plus 9, and there is my nth term formula. Moving on to question 25, it says the first four terms of a linear sequence are 7, 11, 15 and 19, what's the formula for the nth term, in which we should have 4n plus 3, because we've got 4n, well, plus 4, the difference is plus 4. What do you have to get from 4 to 7? Add 3, and there we go. Question 26, it says here we've got another nth term formula, in which the correct answer you should have is 98 minus 8n. And again, sometimes you might have your nth term as this, but what you're looking for is a positive 98 and a negative 8n. And there we have our answer. Then with question 27, it says the first four terms of a sequence, what's the nth term? And so for this, you can see we've got minus 2n. And then to get from minus 2 to minus 10, we need to subtract 8. So I'm looking for that second one there. Then question 28 says, here is a linear sequence, which is the nth term, and which the correct answer you should have is 8n minus 3. And then for question 27, it says, here are the first 5 terms of a linear sequence, work out the nth term. So the difference is plus 6, so we've got 6n. And then what you have to do to get from 6 to 9, well, we need to take away 3, so it's 6n minus 3. And we are done.